All right, this is the view program. We're doing pre-calculus. We're on topic 5, which is intro to the unit circle. So we're doing example 2 here, which is a little bit harder than example 1 because you're going to have to do a little bit of math to figure out the relationship between the unit circle values that you're given, right, on here, and the tangent, cotangent, secant, and cosecant. Okay, so first thing you want to do is you want to find the point on the unit circle. So 5 pi over 6 is on the unit circle, right? You'll see 5 pi over 6 is right here on my unit circle, right? So sometimes I like to actually draw like a little picture of where it is, like that's helpful to me, so it's right here. But that point is going to be a negative root 3 over 2 comma 1/2, right? And then the next thing I need to do is I need to think about what the relationship of tangent is, right? So you may remember from our notes the other day, or earlier, it was the other day for me, but for you it's the same day, that tangent is the y on the unit circle on top of the x on the unit circle. So what I need to do is I need to put this y value on top of this x value. So that's going to be a 1/2 over a negative root 3 over 2, which when we simplify that, I'm going to get a 1/2 times a 2 over a negative root 3, or a negative 1 over root 3. Now that answer is generally fine when you get to calculus, but in pre-calc they're usually going to want you to rationalize, meaning times both the top and bottom by root 3. So root 3 over root 3, and that'll give you a negative root 3 over 3. So that's the tangent that you're going to see in all likelihood, negative root 3 over 3. So now let's do the second one. So to be, I could make a Hamlet joke now, to be, not to be. Anyway, is tangent of negative 3 pi over 2. Now that's tricky because negative 3 pi over 2 is not on the circle. So there are two ways to get there. You can either figure out where regular 3 pi over 2 is, which is down here, and say, okay, so if I went counterclockwise, I'd get down here. And then you could say, what would happen if I went the opposite direction? And you'd land up here at pi over 2. The other way to think about it is that you could add a full circle. If you don't like something, if you don't like a value that you're given, you can add a full circle to find a coterminal angle. So in this case, I would add 2 pi, which would be 4 pi over 2, and you'll realize that this is the same as the tangent of pi over 2. Well, that point is right here, right, at 0, comma 1, right? So my tangent is the y on top of the x, as we saw. So that's a 1 on top of a 0, and the word for that is undefined. You can't simplify it. The answer is undefined. You don't leave it as a 1 over 0. You call it undefined. All right. Next one is the cotangent of 315 degrees. So you can look at your unit circle. I'm not going to keep throwing the paper in front of you because you have a unit circle in your packet, but 315 degrees is right here. It's the 45-degree angle that's in quadrant 4. So this point is going to be a positive root 2 over 2 and a negative root 2 over 2 for the y coordinate, right? So cotangent is the x on top of the y. It's the flipped version of the tangent. So, but you'll notice that these two numbers are exactly the same. Root 2 over 2 and root 2 over 2 are the same number. The only difference is they're off by a negative sign. So you could put the x, the root 2 over 2, on top of the negative root 2 over 2, and you could flip things and simplify and cancel, but it's a lot faster to recognize pretty quickly that your answer is going to just be a negative 1 because they're the same value with a different sign. All right, so cotangent of negative pi over 6. So the negative pi over 6, you run into that same issue, right? Here's regular pi over 6, but I want negative pi over 6. There's two ways to do that. I can either just say, hey, this would be rotating positive pi over 6, so if I rotate the opposite way, I would land on this 11 pi over 6. That's fine. Or you could add 2 pi, which would be a 12 pi over 6. Either way, you're going to realize that this is the same thing as asking for the cotangent of 11 pi over 6. And 11 pi over 6 is right here. Well, that's the point, root 3 over 2, comma, negative 1/2, right? And again, you want to get to the point where you can figure out those points without looking at the unit circle. I'm not looking unless I'm showing them specifically to you. You want to get to the point where they're memorized. Cotangent, again, is the x on top of the y, so that'll be a negative 1/2 on top of that root 3 over 2. Now, you could go to a whole bunch of work to simplify it, or you could notice that this is basically the same problem we did in 2a, just the signs are in the opposite, like on the opposite floor. So you could pretty much skip to the end and say, hey, I'm going to simplify that exactly the same way I would simplify this, and it's a negative root 3 over 3. All right, secant of negative 120. So this is tricky because we need to figure out where negative 120 is. Again, if you don't like the idea of finding the opposite direction of the unit circle, and you certainly could, right? So regular 120 on your unit circle is right here. So that would start here and rotate here. So you could rotate to negative 120 and figure out that it's 240. The other way to get there is to remember that you can add full circles, which in degrees are 360. So you're actually looking at the secant of 240 degrees. Well, that means that you're looking at this point right here, right? The coordinates of that point are a negative 1/2, comma, negative root 3 over 2, right? But secant is the flipped version of the cosine, right? Secant is 1 over the x, the flipped version of the cosine. But the easier way to think of that in your head is you're just flipping the cosine. So the cosine is negative 1/2, so your 1 over the x would be a 1 over a negative 1/2, which just flips to be a negative 2. Secant of 3 pi over 4, well, if you look on your unit circle, you're going to find that 3 pi over 4 is right here. It's the pi over 4, or the 45-degree angle in quadrant 2. So the coordinates there are going to be negative root 2 over 2, comma, regular root 2 over 2, right? Positive. And remember, secant is the flipped cosine. So if you flip the x-coordinate, you're going to get that this is a 2 on top of a negative root 2, but we shouldn't leave stuff unrationalized. So we're going to times by root 2 over root 2. And we're going to get 2 root 2 over a negative 2, so you get negative root 2. Okay, so that's my answer to the that's my answer to 2F. The last one is cosecant of 210 degrees. So 210 degrees is right here on my unit circle. It's the pi over 6, basically, that lives in quadrant 3. And so that point is negative root 3 over 2, comma, negative 1/2. Well, cosecant is 1 over the y on the unit circle. It's the flipped y. So since my y was a negative 1/2, 1 over that y on the unit circle will be a negative 2. You flip the negative 1/2 and get a negative 2. So that's our example 2. I know that's an awful lot of math. As you use the unit circle, you get better at knowing these points by memory without having to look them up, but certainly when you're learning it, it makes sense to have to use it.